I've witnessed the northern lights dance across Arctic skies more times than I can count. But what happened at Karhula Research Station in February of 2019 wasn't dancing, it was descending. My name is Marcus Anderson, and I'm an atmospheric physicist who spent the better part of a decade studying aurora phenomena in the high Arctic. I thought I understood these celestial light shows until 3 days in the Lapland wilderness taught me that the Aurora Borealis still holds secrets that can challenge everything we think we know about our planet's electromagnetic relationship with space. Karhula Station sits at 70 degrees north latitude, deep in Finnish Lapland where the polar night stretches for 2 months without a single glimpse of the sun. It's a place where the silence is so complete you can hear your own heartbeat, and the cold is so intense that your breath freezes mid-air and falls to the ground like tiny crystals. The station houses 6 researchers during the winter months, and we're completely cut off from civilization except for satellite communications and weekly supply drops when weather permits. February 14th, Valentine's Day, ironically enough, started like any other day in the endless Arctic night. I was monitoring atmospheric conditions from the observation dome, tracking the usual electromagnetic disturbances that precede aurora activity. The solar wind data showed moderate activity, nothing extraordinary. My colleague Dr. Sarah Chen was running calibrations on our magnetometer array, while the rest of the team conducted their routine research in the warmth of the main building below. Around 9 p.m., the aurora began, as it always does, a faint green glow on the northern horizon, gradually intensifying into those familiar curtains of light that sweep across the star-filled sky. I've seen this phenomenon thousands of times, but I never tire of watching charged particles from the sun collide with our atmosphere, creating these ethereal displays at altitudes of 60 to 400 miles above Earth. But something was different that night. Instead of remaining high in the thermosphere where auroras belong, the green luminescence began to descend. Not metaphorically, literally descending toward our station like a slow-moving, luminous fog. At first, I thought it was an optical illusion, perhaps caused by ice crystals in the air refracting the aurora's light. But as I watched through the dome's reinforced windows, the impossible became undeniable. The aurora was coming down to meet us. Within 30 minutes, the first wisps of glowing green mist reached the station's perimeter. The electromagnetic field detectors went haywire, registering readings I'd never seen before. The usual aurora occurs when solar particles interact with oxygen and nitrogen at extreme altitudes. But this phenomenon was happening at ground level, creating a luminous fog that defied every textbook I'd ever studied. Sarah's voice crackled over the intercom from the main building. "Marcus, are you seeing this? The magnetometers are showing field fluctuations unlike anything in our database." Her voice carried a mixture of excitement and concern that perfectly matched my own feelings. By 10:30 p.m., the station was completely enveloped. The aurora fog glowed with an otherworldly green light that pulsed gently, as if the entire research facility was breathing inside a living, luminescent organism. The temperature readings remained normal, minus 38 degrees Celsius, but the electromagnetic environment had transformed completely. That's when the strangeness truly began. Our satellite communications failed first, not with dramatic sparks or alarms, but with a gentle fade to static that reminded me oddly of a radio being slowly tuned away from a distant station. The backup radio systems followed suit. Within an hour, we were completely cut off from the outside world, wrapped in a cocoon of dancing light that shouldn't exist at ground level. But the equipment failures were just the beginning. Dr. Chen reported that her digital watch had stopped, frozen at 10:47 p.m., though she could feel it vibrating against her wrist as if the mechanism was still trying to function. The station's main computer systems remained operational, but displayed readings that made no scientific sense. Electromagnetic field strengths that should have been impossible to sustain at sea level. More unsettling were the sensory experiences we all began reporting. I found myself hearing faint musical tones that seemed to emanate from the walls themselves, harmonious frequencies that rose and fell in gentle waves. Sarah described feeling as though she could sense the electromagnetic fields directly, like a tingling sensation that moved through her body in patterns that matched the aurora's pulsing rhythm. Our station manager, Dr. Erickson, initially dismissed these reports as psychological effects of isolation and unusual circumstances. But by the second day, even his skepticism began to waver when he started experiencing what he called electromagnetic synesthesia, the ability to perceive electromagnetic fields as colors and shapes that weren't visible to the naked eye. I spent hours documenting everything, taking measurements and photographs, though the cameras struggled to capture the phenomenon accurately. The aurora fog seemed to exist partially outside the normal electromagnetic spectrum, visible to human perception, but elusive to our instruments. It was as if we were experiencing a form of atmospheric phenomenon that bridged the gap between the measurable and the inexplicable. On the second night, something extraordinary happened. As I stood in the observation dome, surrounded by this impossible aurora fog, I began to understand what we were actually experiencing: the electromagnetic readings, the sensory phenomena, the equipment failures. They all pointed to a rare confluence of atmospheric conditions that created a unique electromagnetic environment at ground level. What we were witnessing was a temperature inversion so extreme that charged particles from a typical aurora were being trapped and concentrated in the lower atmosphere. Combined with the station's location in a natural electromagnetic anomaly caused by underground mineral deposits, the conditions had created what could only be described as a ground-level aurora, a phenomenon so rare that it had never been properly documented by modern science. But the indigenous Sami people of the region had stories about it. Dr. Erickson, who had grown up in a Sami community before pursuing his scientific career, recalled legends of the earth lights that would occasionally embrace travelers during the deepest winter nights. The stories described experiences remarkably similar to what we were living through: the musical tones, the enhanced electromagnetic perception, the sense of being connected to the planet's magnetic field in a direct, almost mystical way. Western science had dismissed these accounts as folklore, but we were discovering that indigenous knowledge often contains accurate observations that simply lack the technological framework for measurement and documentation. The Sami had been witnessing and describing this phenomenon for generations, understanding it through cultural and spiritual contexts rather than electromagnetic theory. On the third day, as suddenly as it had descended, the aurora fog began to lift. The electromagnetic readings gradually returned to normal levels. Our communications equipment flickered back to life, and the otherworldly sensory experiences faded. By evening, the aurora had returned to its proper place in the high atmosphere, dancing across the stars as if nothing extraordinary had ever happened. But something had happened. Something that challenged our understanding of atmospheric physics and human electromagnetic perception. In those 3 days, we had experienced a direct connection to our planet's magnetic field that most humans never encounter. We had witnessed a phenomenon that bridges traditional scientific observation with indigenous knowledge systems, reminding us that the natural world still holds mysteries that can humble even our most sophisticated instruments. The data we collected during those 3 days has contributed to new research into rare electromagnetic phenomena and their effects on human perception. We've learned that under specific atmospheric conditions, humans can indeed perceive electromagnetic fields directly, suggesting evolutionary sensitivities that we're only beginning to understand. The experience has also led to increased collaboration between scientific researchers and indigenous communities, recognizing that traditional knowledge often contains accurate observations about natural phenomena that deserve serious scientific investigation. Most importantly, those 3 days reminded me why I became fascinated with the aurora in the first place. There's something profoundly humbling about standing beneath lights that connect our small planet to the vast cosmos beyond. Whether they're dancing 400 miles above us or swirling around us like a luminous embrace, the Arctic continues to surprise us, continues to teach us that despite all our instruments and theories, nature still has the power to create moments of pure wonder that expand our understanding of what's possible. Every winter, I return to the high latitudes hoping to witness another impossible phenomenon, another reminder that our universe is far stranger and more beautiful than we could ever imagine. If stories like this spark your curiosity about the mysterious phenomena hidden in our planet's most remote places? Hit that like button and subscribe to join me as we explore more secrets from the world's wildest frontiers. The aurora may have returned to the sky, but there are countless other mysteries waiting to be discovered in the endless Arctic night.